Perfect. All right. gRPC, all the things. So quick survey. How many people have never heard of gRPC? No idea what it is. Most people. That's fantastic. Now, on the other side of the spectrum, how many people are gRPC professionals and have used it so much you hate it and would not advise anybody to touch it? We got one person up there. You can talk to this person tonight at the beach and see which end of the spectrum you lay on. So my name's Michael Hamrah. I'm the chief architect of a company called Namely. It's based out of New York. It's a software as a service company that specializes in HR software. That's people management, performance management for your employees, payroll, benefits. And one of the things that we've done in the evolution of our systems is adopt services for our ecosystem, and we use gRPC. And I'm going to talk about how we build gRPC services. So don't worry, there's no live demos. You're not going to have to watch me type in a terminal. But what I did was I put together some code on GitHub. It's available, Hamrah gRPC example, that you can download, you can clone, and you can play around with. And a lot of the features of gRPC and a lot of the code snippets I pulled from this repo, and it's really meant for you as a starting point to hack around with gRPC. You can build services with Docker. You can run them locally with Docker Compose. There's Terraform scripts for spinning up a Kubernetes cluster if you want to try out some of the Google Cloud endpoints functionality. And there's even a GraphQL toolkit that allows you to map GraphQL to your gRPC services. So I really hope you use that to hack around, play around with some of these features after this talk. So what are we going to talk about? I'm going to give a brief overview of gRPC for those who have never heard of it before, talk about what it is, how you would use it. I'm going to discuss some aspects of working with gRPC, how you would use it in your organization, and what patterns emerge and processes emerge around developing services. Obviously, talk about HTTP and JSON support. This is the full stack fest. We want to bring back the web. We should think about what got us here from web technologies to make it so interoperable as we think about the new technologies that are helping us advance in the future. I'm going to talk about the cloud and how the cloud infrastructure, in this particular case, Google Cloud endpoints, can help develop gRPC-based services. These concepts you can adopt in a variety of other cloud providers as well. Kubernetes, everybody's favorite container orchestrator. Where does this fit into the system? And finally, GraphQL, a very interesting paradigm for linking front-end and back-end systems together. How can we use GraphQL with this new way of developing APIs? I forgot I have to move close. How many meters? 2 meters? Boom, there we go. So the first question is, should we even be building services? Now, we can debate about the size of a service. Should it be small? Should it be big? What does micro really mean? But I would argue that that isn't the question. Right? The question is, as we move from MVC-based frameworks that are focused mostly on rendering HTML for a browser, right, our landscape has changed. And it's changed in the way that we really think in terms of APIs and where we can use various APIs. Right? We have tools like React on the front end that are focused on using something like fetch for pulling JSON data. We have new ways and new user interfaces in things like Amazon Alexa and Google Echo that change the paradigm. There's always mobile and the concerns about network bandwidth on the mobile side. And as Namely has evolved, we had a classic Ruby on Rails app. We had a very large C# monolith. We adopted services as a way of decomposing our system into parts that we can assemble together. And that's a very powerful mechanism. It allows you to compose systems and tune systems independently. And what does this look like? Right, so on one side, you have an abstraction. Right? That's the client. You're taking something complex, you're putting it in a closet, and you're presenting some piece of functionality that can be used in a variety of ways. Right? And how successful your API is somewhat in tune of how well you got your abstraction. Right? If you have a flexible abstraction that you can use in a variety of ways, let's say it's a simple to-do system where you're tracking to-do lists, if you have a good API, you can have a web front end that can manage to-dos. You can ask Alexa to manage to-dos, and it's all going to the same back end. And you don't care anything that's happening on the other side of this wall. Right? And then from the service perspective, you have a bounded context. That's a concept from domain-driven design, which is your transactional boundary. That's your closet. That's your black box that you can do whatever you want to do inside here. You could possibly change your programming language if you wanted to move from Melisandre's Ruby to more of a hipster Jon Snow Go. That's possible if you get this line right. But it's not so easy, right? There's not just two sides of this where I have an API and there's something on one side and there's something on another side. In the middle, you have a tremendous amount of cruft. And this is, I think, where a lot of people are trying to solve this problem and mitigate this cruft. And what does this cruft look like? Well, you have networks that can fail, right? So as long as you have a service, there's this boundary that you have to deal with. Maybe you're adding in retries. Maybe you're using Istio in here to facilitate some of the complexity in a simple client call to a server. There's serverless, right? So serverless tries to abandon, I need a server, I need to create a port to start a process to talk to this functionality. It tries to make that bounded context as simple as possible. And even on the client side, right? If you're talking with an API, you usually need to create a gateway class or a facade class to wrap the complexity of your API and deal with calling the API so that logic doesn't bleed into the rest of your system. And so what we're trying to do with this layer of cruft is we think about API development and what the client-server interaction looks like, is we're trying to manage this in an easier way. Right? You're never going to get rid of it, but you want to shrink it down as thin as possible. And if you choose the right tools, then managing this cruft becomes a lot easier. Right? And this is, I think, where we find a lot of the SRE-related responsibilities, where you can have a team that's focused on this cruft, that is managing this process and thinking about the best tools that I should use so that my developers can focus on that business logic in the bounded context side, and my customers have a reliable system on the abstraction side. So what is gRPC? How does gRPC solve this problem? gRPC tries to minimize the cruft as much as possible through the use of code generation and great frameworks in an ecosystem that it built around that API development. So it's focused on an IDL, that's an interface definition language. It tries to distill a service definition into its essential parts. As simple as possible, how can I describe the methods and data that my service uses? It's language agnostic, and you can use that IDL to generate boilerplate code in a variety of languages, right? So Ruby, C++, Java, Go, C#. It's all supported, and you can easily develop a gRPC service where you have one language on the client side and a completely different language on the other side, right? Or you can develop the same service in different languages and see which one you like best and which one performs better. It uses a tool called protocol buffers, which is an efficient serialization mechanism for sending data on the wire. Right? Unlike JSON that has the key value pairs and you're describing the keys and you see a lot of repetition in text, protocol buffers uses a serialization mechanism that just sends bytes over the wire and minimizes the amount of overhead of data payloads through its serialization mechanism. gRPC is based on a concept of plugins. So it uses the ProtoC, that's the protocol buffer compiler. And for each language it supports, and for each extension it supports, you can load a plugin into that ProtoC compiler to get some added functionality. The serialization mechanism is forwards and backwards compatible. So you may have a sense where you want to remove or deprecate a field from JSON, and then that's a breaking change. The gRPC serialization mechanism through protocol buffers allows you to safely add, remove, and even rename fields, and it's not going to break the on-the-wire contract so that your clients and servers can evolve independently, and you can better introduce evolving changes to your services, which is very important as your organization and your technology and your systems evolve. And one of the most interesting aspects is the fact that it is self-describing. It uses this concept of IDLs as a way of describing the functionality that it possesses. So you may be familiar with OpenAPI and Swagger, right? That's more of an add-on, whereas gRPC makes the IDL a first-class citizen of its language. And so what does this IDL look like? Well, this is the code that's on that GitHub repo that I mentioned before. This is a subset of it. And what I'm doing is I'm defining a simple service, to-dos. I have a comment with a getToDo method, simply returns a list of to-dos, and I'm specifying that this getToDo method takes in something called a to-do request, and it returns a to-do object. And then down below, I'm specifying what these messages look like. They have a data type, string, bool, a name, and then they also have a number. And the number is how that serialization mechanism works, because what Protobuf does is that it completely ignores what the name is, and it uses that number, right? So as long as you don't change the data type to the corresponding number, you're safe to add new fields. You can remove fields because you can drop numbers accordingly, or you can easily deprecate fields as needed. And this is just the essence of a service, right? I don't care what language this is implemented in. There's no business logic here. It's really my template. And what can I do with this template? gRPC uses code generation to create scaffolding. So this is one element of the cruft that it removes. What we did at Namely is bake the ProtoC compiler and all of the plugins that we use into a Docker container. It's called ProtoC all. And what we do with ProtoC all is we give it a proto file, in this case todos.proto, and the language that we want to generate. In this case, I want to generate Go code. And I have a volume mount. The volume mount is how I get my code into the container. And what this container will do is it will call the ProtoC compiler. It'll say, I want to generate a gRPC service with Go. It'll handle a lot of the kind of intricacies of calling ProtoC, the right flags you have to pass to get everything working correctly. And then it'll generate my boilerplate code. And what you get with your boilerplate code is a starting point for writing clients and developing servers. The basis of this gen code, the thing that's most important, is an interface. And this is language specific, but in general, languages that support interfaces, you'll have to implement an interface. That's C#, Go. And languages that don't support interfaces, like Ruby, you may get an abstract class that you implement and override. In this particular case, you notice that my to-do server interface has a getToDo method. It has that getToDo request, and it also returns a to-do object. And so I'm responsible for implementing a class or a struct that has this method on it with my actual logic. And once I have that, I can call this register to-do server, which takes in a gRPC server that's from the gRPC framework. And it takes in my struct that implements this interface. And then all of a sudden, I have that gRPC support. I can start making calls. And what we do is we git ignore this file. Anytime that you have generated code, it's highly advisable that you do not check the generated code into source control. Right? It could be very tempting to mix it. It's really a build time concern. And you should be able to generate it easily locally on a build server and do it repeatedly in the same way without having to worry about somebody accidentally making a change and not being able to reproduce it and get some diversion from the tooling and the source control, the actual artifacts that you're generating. So how do we implement a server? I have this interface. And this is obviously language specific. But what I'm doing is I'm declaring a struct. It's a server struct. It has some sort of storage mechanism, which is another interface. And I'm implementing my getToDo method. Now in Go, you'll notice that I'm not declaring that this is a to-do server. That's one of the niceties about the language of Go, is that as long as your struct, your server struct, has the same methods as an interface, Go automatically assumes that you're implementing this interface. And that's pretty flexible from a composition perspective, because you could theoretically have this server struct implement any number of interfaces as long as the methods line up appropriately. So this server method doesn't do much. Right? In actuality, I may add some validation. It's simply calling the read method on my storage. You notice that I have this context parameter. Right? What is context? Context is an important feature of gRPC. It's very prevalent in Go and some other languages that allows you to link a request across a variety of distributed systems. So we've talked a lot earlier about observability, how we can do things like distributed tracing, how we can slice and dice data. One of the important aspects is that if you think of a request from a user standpoint, how do I know everything that that user request went through in my backend systems? Context allows you to pass data from system to system. It also handles things like timeouts and deadlines. Right? You don't want a situation where maybe a high-level service that's handling a user request times out, but your backend systems are still processing this call, doing retries, and generating code. So context is an interesting mechanism that allows you to do that. The other thing that you may notice if you're familiar with Go is that my read method, right, is returning the same types as my getToDo method. Right? The toDo method has a pb.todo and an error, and I can just call read and return the result from that. That means that my repository, my storage repository, knows about protocol buffers. And you may think, oh, that's an abstraction. You're leaking your abstraction. Why would your repository need to know about your API defs? And I think that that's OK. I think that if you're developing a service and that service is small enough, right, it's really responsible for its API contract. And you want to be doing things that facilitate the data that that service is managing, and let the repository make the decision of how you want to store it. Right? You may want to store the raw bytes in a key value database. Right? You may want to extract the fields into a SQL database. You may want to kind of publish something onto Kafka. Right? That's not necessarily a concern of the higher level service. You can push that down into your repository and let the repository do that persistence of that object well. This is kind of a reverse of ORM-based systems. Right? Usually you had tables, you had defined SQL, you would generate an ORM based on a schema design, and then you would force your API to conform to what your database looked like. Right? But as we've seen more complex databases, special purpose databases like Elasticsearch, that model falls out, and this kind of reverses that trend where the most important thing is your API and your API data. So how do we actually use and launch that server? So I would argue that this is somewhat cruft code, but it's necessary cruft code. Right? If we go back to the server implementation, this is almost like a Lambda function, right? This is where you want to be focusing on your code. This is what your service is actually doing. But we need to expose it somehow, and how do we do that? And so in our server code, what we do is we create a listener. So we want to listen on a port, in this case 551. I'm creating a new gRPC server. That's from the gRPC framework. And each language has a method that will give you a new gRPC server. I'm calling my register todo server. That's from my code generation that we saw earlier. I'm passing in the gRPC server that I created, and I'm passing in that struct that implements that todo's interface that we need. I'm just giving it a simple memory storage. And then this next line, reflection.register, is where we get that introspection. This says that I want my service to be able to explain the methods and the types that it does. Right? You may not always want to do this, but usually it's very helpful because it allows different clients to ask your service, hey, what methods can I call? Right? You can imagine OpenAPI, if you had a swagger.json file, it's very similar. This is built into the language, and it's all generated from that single IDL. And then finally, we just listen. If you're familiar with Go, this is very similar to launching an HTTP service. And on the client side, how do we use this? Well, it's very simple. We dial to our backend host. I'm just using with insecure here for simplicity. I'm creating a new todo's client. This is from that auto-generated code. It will automatically generate an implementation that implements that todo server interface. I don't need to give it any actual implementation because there's nothing to implement. I just need the client. And I'm calling my create-todo method. I'm creating a new context in the background, and then I'm passing a create-todo request, and then I'm just printing out what the response is. Now, I don't need a repository layer. I don't need an interface or an abstraction because I already have one. Right? It's from that IDL. Right? I don't need to rewrap an interface. I can easily mock an interface. I can easily replace the implementation if I wanted to. Most likely, if I was changing my client-side code to call a new or completely different service, it would be a large change. And if you can't implement the existing interface, you'd be adding new functionality anyway. Now, how would I use this on the command line? Somebody last night asked me about curl. gRPC has a tool called grpc-CLI that allows you to make calls and also introspect what a server is doing. So in this case, I'm listing all of the methods that are available on my todo service through that introspection endpoint. So these are all of the things that I can call, which makes discovery very, very interesting. And I can find out what types I need. And to make a call, I call my create-todo method. This kind of looks like JSON, but it isn't. But it's that todo message structure. This is the todo that I want to create. And then I connect, I call it, I get back my response, and I'm spitting out the ID and the title, and I see that it succeeded OK. So this allows you to play around with services very easily from the command line, which kind of facilitates the learning and onboarding. Now, the important thing to note is that that's great for one service. But your service is really one of many, right? You're not going to just have one service. You could, but most likely you're going to have a bunch of these. And how you manage all of these services is something that I think a lot of people don't answer soon enough in the development process. You usually end up with a mess of services, and then how do I debug it? How do I run it? How do I handle a lot of these retries? So this is where your infrastructure choice and something like Kubernetes comes into play. But there are two patterns for developing gRPC services that are important. Your services should look like each other, right? You don't want one team to use save and another team to use update, right? From your customer's perspective, all of your services should have some familiarity to them. And creating a style guide can be essential for an organization to help teams operate independently, but guide them in the right direction to make the right decisions. Google has a great style guide on API design. It's not gRPC specific. If you haven't seen it, I strongly suggest looking at it. It's certainly opinionated from a Google point of view, and it helps explain some of the Google API decisions that were made, and you can adapt it to your own needs. In Namely's case, we based our style guide on Google's and made some changes that were more important to our organization and the way that we want to develop APIs. And the general themes that we promote are small API services. Right? Your API or the backend service that you're developing should do one thing and do it well. You should be able to describe it with a simple sentence. Right? My service saves, updates, and allows you to search to-dos. It doesn't also handle kind of group management or lifecycle management or users or anything else. It just handles to-dos. You want to be resourceful and think in terms of resources and the life cycle of resources. One of the big criticisms of RPC in the past is that they were very chatty. You had a lot of methods that each did something kind of different, and you didn't know which one to use. Your service doesn't need to have 20 or 30 dozens of operations on it for specific purposes. You can kind of distill that down to a simple set of life cycles, and that's going to give you a really good abstraction. It's going to give you a lot of affordances so that you can use that API in a variety of circumstances, not necessarily the specific UI that you're dealing with. You also want to include a concept of events, right? Event-driven architectures, things like Kafka, data analysis, event streaming. These are becoming really important in our ecosystem. And an API, I would say, is only one half of this coin, right? The events that are emitted from your service in that asynchronous, disconnected nature are very important when we think about a service, not just the API that's defined in our IDL. We use Kafka at Namely, and we use protocol buffers as the serialization mechanism for Kafka. Sometimes you see JSON, sometimes you see Avro in this. We find that swarming on protocol buffers has worked well for us, and that's what we use, and it's efficient. The forwards and backwards capability help in evolving events as the system evolves. And then in terms of the consistency, one of the things that we do is we have a Proto repo. So you may be familiar with the concept of a mono repo where all your code is in one place. We have a Proto repo for all of our IDLs. And this allows an organizational awareness of how an API across your entire organization evolves. So each one of these folders represents a specific service. We have pull requests that go into this so we can comment on API design. We can ensure consistency. We have an understanding of why we're adding and launching a new service. And we can very easily see all of the services that exist in our system from a development standpoint. And what you would do as a developer is submodule this repo into your code repo. And then if you needed to get an update, you can just do a git submodule pull, and then you can choose to auto-generate whatever services you want to talk to or implement through that Namely ProtoC code generation tool that we have. Maybe? Closer? There we go. So gRPC is great, right? It's this efficient binary serialization mechanism. You can generate clients and can generate servers, but what about HTTP and JSON, right? What about the web? Can we still honor the protocol and the tooling and the frameworks that have evolved the web so much? And the answer is yes. And so one of the beautiful things about the IDL is that we can say, hey, I'm creating protocol buffers, but can I also do this with HTTP and JSON? And the answer is you can. So the protocol, the gRPC system supports a notion of options that allows you to extend the functionality of the base gRPC framework. And in this case, we're creating an option that wants to describe an HTTP API. And so for my update to RPC method, I'm saying that I want to make this available using the patch verb, right? It can be get or post, or you can think about what do I want to use, post versus patch. In this case, we're using patch. And I want to make it available at this URL, at this path, todo/todo-id, right? Todo-id is a wildcard, and it's going to set a field in my update todo request. You can see in the IDL file that update todo request has a single todo. That's the thing that you want to update. And then finally, I want to map the entire JSON payload, that entire JSON body, to my todo field in that update todo request. And we use another code generation container, in this case, gen grpc-gateway, that will output a file that will take a handler, a URL router, and map it to a request and handle making the gRPC call to the backend. Now, what we did was we added some functionality to this gRPC gateway. It's open source. You can take a look at it. And we give you a Docker file and a main method that has an actual server so that you can sidecar this. So with this 2 lines, you have a Docker container that you can launch. You just give it a backend that you want to talk to, and it will proxy all requests to that backend. Right? This is that sidecar model that we saw with Envoy and Istio, but instead of being an entire service mesh, we're just being very specific with this gRPC proxy. So you call it, you call the gRPC gateway in HTTP JSON. It figures out what route you are, which gRPC method you need to call, calls it, and it'll send back the response. And that looks very similar to our gRPC CLI command. Right? I'm curling my to-dos gateway. This is in the Docker compose file in the repo I showed earlier. I'm going to the to-dos path. I am giving it a piece of JSON data. Because I'm giving it curl data, it's automatically going to infer this is a post request. And my response is the ID of the newly created to-do. It also supports Swagger, so if you have a Swagger or Open API-based ecosystem, you get a swagger.json file that describes the IDL that you can curl for that level of introspection, right? So you're not forced to using the gRPC IDLs. It can go from a gRPC IDL to a swagger.json file for that rich ecosystem of API introspection. So a lot of this work involved a do-it-yourself approach, right? You have to run containers. You have to generate code. Is there another alternative that can facilitate some of that infrastructure work that goes into it? And there's a variety of solutions out there. We heard earlier how Envoy can do the HTTP to gRPC mapping. Another aspect of thinking about running in production is that observability aspect. How do I know how many requests, what the latency is? How do I handle logging? And so Google Cloud Endpoints is a product that allows you to automatically inspect traffic. It supports gRPC and HTTP. And we can use that to give us some observability tools for free. So how do we do this? Well, leveraging IDLs, the interesting thing about proto files, about these gRPC proto files, is that you can describe it with another proto file. So descriptor.proto will give you the abstract syntax tree, the AST, of any proto file. And I can use ProtoC, the compiler, to generate a serialized protobuf message that I can load into a descriptor proto file and then understand programmatically what methods, what types, even what comments are in that IDL file. And with that descriptor proto file, because this describes my API, I can send that to a central server, in this case, Google Cloud Endpoints, with some YAML-based config that describes how I want to interact with this API. And you get a lot of interesting features I'll show you. And with this YAML file, it talks about usage, so I can add authentication. I don't need to bake authentication into my service. I can use it to interact with a variety of different other API authentication providers. I can even add my HTTP mapping rules into this YAML file if I didn't want to pollute my main proto file, right? I personally prefer to have your mappings within the same IDL, so everything is together, but you can easily make an argument that the two should be separate. So by creating a YAML file, by creating your API descriptor file, and by loading this into gcloud endpoints, you can start inspecting traffic. And so the endpoint service proxy, ESP, is a sidecar container. This is not generated. This is standard. It's open source. And this runs alongside your service similar to gRPC gateway. But what this ESP container does is it loads in that descriptor file from the endpoint service, and it sends logs and metrics back to the Google Cloud Platform. And you send all of your traffic, including your gRPC traffic, to ESP, and ESP interacts with your service. And what you get is very interesting latency dashboards and metrics that tells you how well your service is performing, right? What is your median? What is your 95th? What is your 98th percentile? And it also tells you what methods are being called and what the request and response size is. And you get this for free. I didn't have to create this dashboard. I didn't have to build it. Simply by creating that descriptor file and loading a config into endpoints, I get this great overview of my services. And when you have 20 or 30 of these, you've essentially automated dashboard creation, which is a great first stop to observability. You also get a developer portal. So if you notice that, in this case, to-dos create to-do, there's a little description there. That was pulled from the IDL file. That was a comment that I wrote in my gRPC file that was extracted and created automatically for this gRPC portal. And it tells me what the REST endpoints I can call, what the gRPC endpoints are. I can mock HTTP calls here. I didn't have to set anything this up. This was simply generated based on that descriptor file that was created. And this really helps like learning about APIs, right? The Proto repo is more of the development process, but this is what you're actually have in production and what you want to use and call. Now, how do we call all of these services, right? We've thought about kind of one service, and we have a gateway to one service, but when I have a lot of them, how do I make my API appear consistent, right? My clients, my customers don't want to kind of figure out which of the 30 dozen services need to do what. I want to present a single unified API and stitch everything together. Right? There's a variety of tools that do this. You have Nginx that can proxy from front ends to different back ends. In this particular case, I'm using Kubernetes and an ingress controller in Kubernetes to route traffic. Right? We saw how Istio can do something very similar. You can use Istio for the same purpose. Right? Maybe you don't want to adopt the entire Istio platform. You want to stick with the native Kubernetes components. And Kubernetes ingress can do this for you in a much more simplistic way than you can get with Istio. But in this particular case, I'm saying that all traffic coming in via HTTP, I want you to do a path match. If your path is to-dos, send it to my to-do server service. This could be running in Kubernetes as a service endpoint. But if it's the user's endpoint, send that to the user's server. Right? So I have a single entry point for all of my API traffic, but I can divert that to a variety of backends using Kubernetes ingress. The other great thing about Kubernetes ingress is that the implementation of the ingress controller is customizable. So there's an Nginx one, there's one that runs natively on Google Cloud, there's an AWS one, and you have a whole suite of emerging companies, Heptio is one example, that implement the ingress spec that provide varying degrees of functionality that may make sense for you and your organization. The last thing to touch on is GraphQL, right? I'm really excited about GraphQL in the way that it rethinks client-server interaction. If you're not familiar with GraphQL, it too uses an IDL. It has its own spec. And it allows you to query or mutate or subscribe to different data streams and specifically ask for the fields that you want to return. So you may have been in a conversation as to, like, what does my REST API look like? How do I do field selection? Should I kind of return this large object? Should I return this small object? Should I use HTTP headers to determine what fields to return? GraphQL tries to create a standard for this interaction. Most GraphQL tools require you to write a GraphQL schema. And that's unfortunate if you're already using gRPC because you already have an IDL, right? So why would I create another IDL just for GraphQL, and how do I merge these together? And that's where this tool called Rejoiner comes in. This is a Google Rejoiner. It's not an official Google product, but it is evolving pretty rapidly. This is based in Java, and in that sample code, I've created a simple Rejoiner project that uses GraphQL to call gRPC. And what Rejoiner does is it exposes that Proto file, that gRPC IDL file, into the GraphQL type system. So instead of starting with a GraphQL schema, you start off with a gRPC schema, and then you can describe how you want to present that in the GraphQL world. And it also supports stitching. So if, let's say that I had a to-do service and that had a user ID, and I wanted to get the username from the user service, how do I link those together? Rejoiner allows you to programmatically decide how you want to link various services together and easily combine multiple backend services into a truly unified API. And we'll see how that works in a bit, if I can get close enough. So this is some very verbose Java code, but there's essentially two things going on here. At the top of the screen, I'm declaring my schema and what that graph schema looks like. And I compose my schema through various modules. So my first module is the schema provider module. That's the magic that stitches everything together. I have a to-dos client module. That's my client library that was generated from the gRPC ecosystem that says, if I need to talk to to-dos, use this client. And I have a to-do schema module, which is how I want to take the to-do service and expose it as GraphQL. And in my to-do schema module, I have a query annotation. This is a GraphQL query that says, if you query to-do, call this method. And it just so happens to be that this is the same getToDo method as my service, but this is where you can start getting some diversion if you wanted to kind of represent your types a little bit differently. What it does is it takes that return parameter, that to-do parameter, and it will manifest that as a GraphQL schema. And it will automatically inject a getToDo request in a client into this call, and then I can do whatever I want to do from this implementation, right? So if I decided that I wanted to combine users and to-dos, I could implement that in this graph and have a lot of control and customization of how I build my GraphQL system. And from the end user standpoint, there's a GraphQL. This is a simple user interface for interacting with GraphQL that you can call. And you can see my query is my to-do query. I'm giving it the input. That's the ID that I want to return. And I'm saying that I want my ID and title back. And you can see that in the middle, that response that I get from the GraphQL endpoint. And finally, all the way over on the right is that query introspection system. So because of that mapping, I can easily, in the GraphQL language, specify which fields and data types that to-do object has that I can use in my selector. And I think that's the final piece of where you can layer a lot of functionality on a very simple, simplistic-based gRPC service in a variety of contexts. So that's it. Thank you very much. If you have follow-up questions, you can find me on Twitter at mhamrah, and there's my email address. And I'm 3 minutes under, so maybe there is time for 1 or 2 questions if there are any. Thank you very much.